Hello everybody, welcome back to my channel. Today we are going to continue on with our proof. Again, we are trying to axiomatize. We're trying to take the word sensorality, the natural ability or inclination to censor something, which comes in two parts. Physical systems with no sentience, just like my pen can't think, it can't move for itself. I can think and I can move for myself. I'm a sentient being. I have sensorality with an S. This thing filters based off of its mass, how much physical size it has, and makes it censor things. Right? If I drop that and it hits my notebook, the notebook is censoring the pen. So now what we're going to do today is start to apply a lot of these logical ideas and empirical facts to structured linguistics. How can we take our mathematics and physics, rhythm, vibration, and these different proofings and identities of numerics we have, and how can we apply them to language itself? So we're going to go through a bunch of different ideas and structure there, just continuing it on with our proof, trying to provide new insight. So I don't know what I'm going to call this one, but remember in the last one we described and kind of identified that reality, literally the word reality, is the prefix re, to do again, and ality, the suffix sensorality, speciality, chirality, formality, all of these different words. It creates total generality within a concept, within an idea, and the letters represent those concepts and those ideas through written words. And so we're showing that we're deriving the axiom of sensorality, but we're going to explore how can we have any numeric relationships. Can we say there's this amount of prime numbers per vowel, there's this amount of syllables for vowel or per word? What kind of numeric statements can we make about words, about sentences, and about logical structure in its entirety? So again, kind of just thinking out loud, playing with the different ideas, trying to put them all together. So what can we say about word expansion? Again, we have fundamental physics, our universe is expanding. What can we say about the expansion of word? And we have a very clear problem we're trying to solve now. How do we relate the word censor with an S, which is as evident by iteration throughout the species, meaning you go pick up a dictionary, look in any dictionary from one language to the other, try to define the word censor with a C from any language, and it's in pretty much every single language. Try to define censor with an S, it's in very, very few dictionaries. And that's the same even amongst dictionaries from language, amongst the same language, like an English dictionary to an English dictionary, or a thesaurus. And so we're trying to find a connection between the word censor and some other word to solidify the axiomatic concept that sensorality represents. And so, but just in general, what can we say about word expansion? And so I have that in reality, R as a prefix, ality as a suffix, and so I kind of view building words as kind of like you have a center, right? We have any prime number, like the number 3, on a well-defined number line, meaning there's points for each number, 1, 2, 3, you have a well-defined point. There's a point that is the center of that line. Even numbers do not have that. So can we apply that numeric fact to language? How can we say words build by putting, a consonant or one letter on this side of a vowel or that side of the vowel, putting a consonant on this side of a vowel or that side of the vowel? How do vowels repeat? How do vowels iterate? And what can we say about that numerically? And so some things we have right now is, again, we have tenses, past, present, and future. Again, right, the past is solidified, the present is pretty much what we're talking about now, and the future you can't talk about because it hasn't happened yet. And then but that's just, again, that's numeric, that's 3. We have 3 tenses of verbs, of verb conjugation. The minimum amount of words you need for a complete sentence is 2. You need a noun and a verb. And again, if you're in person, typically the noun is the implied the implied word as opposed to the verb. Like if me and you were in person, and there's a bear running at us, and I just say run. Obviously, I'm talking to you, so you would be the subject. You run. You know, I want to say you run. It's just very clear who I'm speaking to. So we have a minimum of 2 words for a complete sentence if there's no implied subject or implied verb. Because I do believe I read there was some languages where the verbs, or the vowels at least, I don't know about verbs, but vowels were certainly implied as opposed to the nouns. But that might just be vowels as opposed to verbs in totality. But again, anything with an odd number, an odd amount of letters has a well-defined middle point. If that point is a vowel or a consonant, can we somehow define or solidify some sort of numeric statement about how words generate and build from one side of the tension point, one side of the middle, to the other side? And so then I just have a question: is there radial symmetry? Then I just have immediately, symmetry does not exist, again because of chirality, but just in general, is there some sort of apparent or attempt, and I say attempt not like the universe intended for there to be symmetry, but is there some sort of structure very close to something that is symmetric but isn't because of chirality, just meaning it's really, really close to symmetric but it isn't. But what you do to one side of an equation, you must do to the other. Again, in mathematics, can we apply that logic to words and to sentences in general, or combined? Like, it is what it is, right? As a sentence, can we say something, right? The word is the equation sign in mathematics. So what can we do? What can we say logically about, again, is being the pivot point, what we do to one side of the equation, one part of the sentence, what must we do to the other side of the sentence? That really is kind of where we get verb-noun agreement. And again, just where you put what's the natural order of nouns, verbs, and adjectives, right? Like if you're learning Spanish, they'll tell you to say de donde eres, but I say donde eres de, from or of where are you. To me is a lot less clear, less specific than where are you from, which is how we say it in English. So I think there's a fundamental physical motivation to have orders of nouns, verbs, and adjectives, specifically irrespective or irregardless of a given language in general. But can we say any sort of numeric statement about that? Again, with the concept of chirality, meaning time moves forward, we're going to use new words to describe different things. We only have a set amount of sounds. We have to iterate those sounds. How does that iteration process fundamentally work in relation to numbers? But just for some examples, right, we have Ili, like that's a lot in the Slavic, the E, like the backwards N, L, E. English or the Roman alphabet languages. And I apologize for my stuttering. I typically don't stutter. This is what I'm talking about. Like I'm on the edge of known knowns, and I have to put together the logic and then use the words. And by the time I've put the logic together, I'm articulating it for the first, second, or third time and putting it onto a video. So I apologize for the choppiness, but the logic should be consistent. But for example, visibility. I'll try to put some more words, try to get my editing a little better. But visibility, right? It's just the only vowel in the entire word is I. It starts with the letter V. Again, is it important what letter a word starts with? I'm sure it does, but we've articulated very well that, and very empirically obvious, that when a word ends with the sound E, now let's make a very clear difference between sound and letter. Letters represent the sounds. The sound E, at the end of a word makes it open, right? There are no closed systems, so we have to apply that logic from physics to linguistics. How do we have open logic structures, right? Something's going to come tomorrow that we have to talk about, so how do we keep our set of known knowns open to where we can discuss things into the future? But again, same way with the, but in general, when a word ends with the letter or the sound E represented typically by the letter Y, it's as general as it can be. Again, in relation to our logic periods from the previous episodes or previous lectures, whatever you want to call them. But so we have that visibility. Again, is just a good example of you see the letter I, starts with a letter, it ends with the letter Y, and the sound E, visibility. And so we're representing the sound E with the letter Y. We have an iteration of just the vowel I and a bunch of different consonants. So again, just an example, but what characteristics or what characterizes the beginning and the ending of a word? Again, the sound E, just discussed that. Connects that with logic. I was going to say something else. Again, just that it applies to, so completeness. Now we pull in the concept of completeness, right? We have complete words. We have locally complete systems. There's no universally closed system. Everything is connected. Nothing is touching. But you have locally discrete. You have local discreteness. My pen can move independently of myself. This word is independent of that word. And so we have continuity of sound, and then we differentiate them to have different words. How do we consider chirality, uniqueness, and sentence construction? Again, specifically to the axiom that we're trying to prove. So now what we have is we'll have a one-way, unique, logical statement. Though again, it'll be empirically obvious. I can say it to you at a bar in 2 seconds. You know exactly what I mean. It provides new insight. It will be a one-way sentence, but it will show the entire logical iteration, not just the iteration of the letters of a given vowel, of a given consonant, but of the logic of a complete thought. And so that's really what will be an axiom, and that will be at the complete generality, at the very boundary of known knowns. And there's infinite axioms that can be proven. And so we're just trying to figure that out. A sentence is a string of sound represented by shapes called letters. Everything is one of a kind, that is unique. So sensorality, with an S, must have a unique definition that pairs with a physical phenomenon. Now we have that, the act of creating sound itself is physical, but now we're going to take these letters that represent sounds and show how one-to-one pairs with a physical process. And then that will, once you solidify that with the letters, that it becomes an axiom. And again, because it's physics, no one can deny it at face value. This is where alliteration comes from, right? We have empirically evident, we have things called like rhyming and alliteration and onomatopoeia, right? So unfortunately, or we'll get to that, but this is where alliteration comes from. Same letters, sounds for the beginning of a group of words. Google gave the example, Polly's prancing pony performed perfectly. So now think about language as a whole. Ideas and concepts and words that start with the same letter have an inherent relation already. They start with the same word. At some point, people decided this sound is most apt to reference this thing. So alliteration is getting away from alliteration, right? People would kind of see that as juvenile or adolescent, or kind of like, are you doing a song or sing-songy? Are you doing something like, what are you doing? If you're very alliterative, people will think you're putting on a performance. They won't see that as natural conversation. And so that is evidence that, again, differentiating, making things different, provides more value, makes things more interesting. It has less small talk. I mean, this isn't small talk, but the example is just any sort of alliteration. People getting bored or kind of off-put by alliteration, or just kind of confused by alliteration as to why you're doing it, shows that spreading out the vowels, the consonants and vowels to different things is more natural or is more normal, but it's showing generalities, differentiating into specificity. And then it has the busy bee buzzed by the bay. This is where onomatopoeia comes from. The hiss or meow or crash. Words that are formed by mimicking the sounds they describe. Again, onomatopoeia is effectively the exact opposite of what I'm doing. I'm taking the finished logical statement and deriving it to the actual sound. And the existence of onomatopoeia is that first break from physical existence, objects making sound, into solidified logical statements, meaning the word meow means meow, and then you say it like meow, like a cat actually articulates it. And so I just have this clear image in my head of this iteration process. Again, I would just call this the iteration function of geometric linguistics. Again, we have dimensionless analysis, geometric linguistics. And this iteration function is what I'm trying to figure out. How exactly do consonants and vowels iterate to continue logic, to have the structure of language that we see empirically in our everyday lives. But I have the Indian run analogy. If you don't know what an Indian run is, it's when you're running, let's say you're training for a soccer team, and you're running in a line, you have 5 people, and then the guy at the back of the 5 people has to run up to get into the front, and then pushing the people back, and then the person in the back always has to sprint up to get to the front, and the other people are jogging. So I view language iteration as that, whereas again, we have a set number, we have the same 5 people, we have the same 26 phonemes or phonetics that we can articulate based on our geometry, our physical structure, and then we have to iterate that to articulate a bunch of different things. But it's the same way where it's like, password encryption. We only have so many letters and numbers, but then if you have 10 characters or whatever, again, I don't know the standard for SHA encryption these days, but you have a set number of the basis, but then you iterate it so many times, and it takes you 14 million trillion times the life of the universe to do this computation. And so that's how much how much range there is to language and what it can describe. But we're always like the Indian run. We're always iterating those different sounds into different sequences. And so to axiomatize sensorality, we're going to show that entire process of each syllable is one of those runners in that Indian run pattern, and we have to show the iteration of all of it. And that will establish the bare minimum basis where everyone knows that it is true, and it's a fundamental axiom of how the world around us works.